All right, we're live.
Hello. Welcome to the Minnesota Solar Challenges webinar on local best practices for solar planning, zoning, and permitting. We'll just kind of run over quickly what we're going to go over today. We have as our agenda. First, I want to talk about what is the Minnesota Solar Challenge and why are we all gathered here today and listening to discussion about planning, zoning, and permitting. We'll go have a solar energy primer to make sure everybody's has the same foundation of knowledge in regard to solar resources and solar technologies, which is a critical component to really understanding why local government needs to be engaged or should be engaged in this whole question. And then we'll go over the planning best practices, zoning best practices, and permitting best practices. This is a version of the presentation that we do, more extended, longer time, a 3-hour presentation, a workshop that we've already done several points in the state, and we're going to do a couple more after this. So if you if you feel like you need to hear this again, but in a more detailed fashion, you can attend one of our workshops. So anyway, let's talk first about exactly what is the Minnesota Solar Challenge. The Solar Challenge is part of a larger national program called the Department of Energy's Sunshot Initiative PV Rooftop Challenge. Quite a mouthful there. But it is a national program that's what we call a market transformation program. The effort here of the Sunshot Initiative is to find how to make solar energy a large component of our nation's energy portfolio in a way that's self-sustaining economically. So the program goal is to make solar electric generation widely cost competitive with conventional grid sources of electricity by 2020. And this is being done in a variety of different ways. The Rooftop Challenge is one component of that. There's also a whole series of efforts that are dealing with manufacturing efficiencies, efficiencies of panels and power electronics, a whole host of things that I won't be talking about today. But just to let you know that this is part of a much bigger effort, kind of market transformation effort around solar energy that's being conducted at the national level. And the overall goal of the Solar Challenge is to drive the cost of solar energy down from where we saw it a few years ago, up around $8 a watt, down to $1 a watt. And that's a program goal. It is a little bit more complex than that. $1 a watt is an easy thing to remember, $1, 1 watt. There's actually several goals in here that I do need to mention. For residential installations, we don't intend to go down that low. But nevertheless, this whole effort is kind of looking at how we drive that cost down from a higher level down to this kind of target cost where we will create a self-sustaining solar energy market. And DOE has looked at this analysis on the basis of how much of this cost needs to come down in terms of the PV module itself, the photovoltaic module that goes on the roof, things like balance of system cost, power electronics, how do each of these need to come down, and what are the pressure points to do that. And it kind of started with this whole concept of solar panels coming down in cost dramatically over the last 30 years. There's been existing investigation into manufacturing powers of a scale, economies of scale, so a logarithmic chart here showing how much you ramp up versus how much you get in terms of cost savings, looking at the entire installation cost rather than the panel cost and the current trend and how that can be driven down even further, looking at the non-panel costs such as power electronics, balance of system hardware, balance of system non-hardware costs, where the existing costs are and the goals, and then even going further than that and looking at things like the soft costs associated with local government operations and utility operations associated with installations, permitting, inspection, and interconnection costs. And so here it all is in German, if I haven't confused you enough, so everyone clear on where we're going here with the Sunshot Initiative? Probably not. But the point of all that running through there is that I don't want to spend a lot of time on the background, but just to help you understand that there's been a tremendous amount of research and analysis that's happened on every one of these components of what it takes to put a solar system on the roof and make it cost competitive over the long term with grid-powered electricity. So the one message that local governments need to take out of that quick run-through of what the Sunshot Initiative is that DOE has determined that it really, if we want to have a self-sustaining solar energy market in Minnesota and nationally, local governments are a critical partner in creating that market. If we don't have the participation of local governments, we either won't get to that self-sustaining solar energy market, or it'll take a very long time to get there. And I'm going to explain why that is, why local governments need to be participating and have a self-interest in participating in this market transformation effort that we call the Minnesota Solar Challenge. So the Department of Commerce is the local or the state entity that's implementing this national level program. There are 4 components to what the Department of Commerce is doing in regard to the Sunshot or the Rooftop Challenge. One is to improving solar access, zoning, and development regulations, streamlining permitting and interconnection processes, improving net metering and state policy issues related to net metering so that it's transparent and easy to capture the financial benefits of solar energy, and then to improve financing options for solar over what we are looking at now. And the piece I'm going to talk about today are the first 2 of those. This effort is what the coordinator team that's been hired by the Department of Commerce is working on, specifically to improve solar access zoning and development regulations, and looking at streamlining permitting and interconnection work. And so that's what we're going to be talking about today, rather than the other 2 more policy-oriented components of the program. So the way that Minnesota Solar Challenge is working and the way we're working with local governments is we're developing best practices that are based on the national best practices for how local governments can participate and help drive down the cost of solar and make it a self-sustaining local market. And we're adapting those national best practices to Minnesota's local government environment and laws. We're then promoting the best practices, those adapted best practices, to local governments through a variety of organizations and outreach efforts, including this webinar and the workshops I mentioned earlier, as well as working with other organizations such as the Clean Energy Resource Teams and the Minnesota Renewable Energy Society to bring these best practices to a variety of audiences, both local governments and private sector individuals such as contractors, so that we can actually get them implemented. And then finally, we're providing direct technical assistance to local governments in adapting these best practices to local conditions and priorities. Because every community is different, and we can't just take a single model and say, here, go do it. We really need, local governments typically need to have some assistance in how those best practices are adapted to their conditions. And so we're actually going to be working with at least 20 local governments in Minnesota to specifically adapt the best practices to their situation. So anyway, before we go in to start talking about what those best practices are, we're going to run through a little primer here on understanding solar energy resources and technologies. And the first thing we have to say always, just to make sure everybody understands, is Minnesota is not a cold and dark place. It actually has a very good solar resource. You can see the solar resource map here that was modeled back about 10 years ago by the Department of Commerce, showing the variation in solar resource across the state based upon several factors. The entire, it's important to note though, the entire variation you see here from the best spot to the very worst spot, best being in the red, worst being in the green, is only about 15% across the state. So there really isn't that much variation in the actual resource that you see on a geographic basis across the state. But we need to think about that resource then in terms of kind of what is the size of the resource. And I asked the question, if solar energy was oil or natural gas, how much would we have? What is our solar reserve here in Minnesota? And the one way we can talk about that is how much land would we need, for instance, to meet 100% of the state's electricity needs with just solar electricity on a net production basis. Of course, understanding that we really don't want to try to do that, at least not yet, because we don't, the sun doesn't shine at night. So, but if we wanted to have an equivalent amount of generation, how much would that take? Which is the total we use is about 87,800 million kilowatt hours a year. And the answer is that it would take only about 1/4% of the state's landmass in order to produce 100% of the state's electricity needs, the size of that green dot. And that just gives you a sense of kind of what Minnesota's solar reserve is, that it's really pretty tremendous, that we have a tremendous solar resource here, and this is using existing technology rather than any future forecast technology in order to generate this electricity. So we have a big solar reserve here in Minnesota, and the question then becomes, you know, we're really not using it at all, or very little, and how do we go about actually doing that in a way that is economically sustainable? So when we look at the solar resource, it varies, of course, by several things that people, I think, understand intuitively. Time of day. The resource varies, is there in the day and it's not at night. It varies across the season, as this graph kind of shows, when the sun is lower in the sky versus higher in the sky. And it varies by local weather patterns. We do have a few places in the state where it tends to be more cloudy, and those that where it tends to be more sunny. And those are kind of the things that went into the map that you saw earlier, showing Minnesota's solar resource across the entire state. But perhaps most important is that Minnesota's solar resource varies by changes in local landscape. This is actually far bigger of a variation than you see based on season or local weather patterns. The sun shines everywhere, we like to think, but in fact what we need for solar energy is direct sunlight, and direct sunlight over a period of time. So the local landscape really defines that. Topography, you know, the north side of a hill versus the south side of the hill, on-site obstructions, whether those be buildings or trees, obstructions on adjacent land to the south of where you are looking for your solar resource, buildings and trees, etc. And then future obstructions, because we are building a piece of infrastructure when we talk about solar energy, and it's not and it has a 30-year lifetime, and we want to make sure that not only do we have a clear path to direct sunlight now, but also into the future. And when we think about the local solar resource, we need to understand that an adequate resource is unshaded for several hours a day right around solar noon, both now and well into the future. So just because sun shines on a rooftop for a brief period of the day doesn't mean that that rooftop has a solar resource. And this is important to understand because obviously the choices that we as local governments make about where buildings go, how we want to deal with resources, has a great impact on the amount of resource and the accessibility of that resource to people who want to take advantage of it. So the local landscape defines the solar resource and access to that resource. And we have a variety of technological options to allow property owners to capture their solar resource, depending on where the location of the resource is on the property, the quality of the resource, which is really determined by how much shading there is and at what time of the day, and the desired end use of that energy, whether you want it to be in electricity or heat, different ways to capture the resource. And these technological options are very important for a variety of reasons, again, at the local government level, when you're trying to determine how you can, as a local government, foster solar energy development within your community. Technological options include photovoltaic or solar electricity, which panels that produce electricity from direct sunlight, solar thermal, where the collectors, the panels, capture sunlight and transfer heat to water or space heating needs, and passive solar, where the basic structural elements of the building become kind of the collector and there isn't a separate panel, and this can be used to provide just daylighting, ventilation, heat, these things through good passive design. Now we will be talking today about the first two of these and not the third one, because the third one has some unique characteristics that are very different from the first two, which are what we call active solar systems, as opposed to passive solar systems. Another technological option that's very aware of is how these collectors are actually attached to the building. So we can see roof-mounted systems where the panels are actually up on the roof, and they can be either flush mounted to the roof or non-flush mounted, where they're pitched at a different angle than the roof is. We have ground-mounted systems where they're not attached to a building at all, but rather just on a pole or a rack out in the ground. And we have either stationary systems that just are pitched at the optimal pitch to the sun for year-round use, or tracking systems that actually have a little mechanism on them that follows the panel follows the sun across the sky during the day. And then third, we have a category we call building integrated systems, which are where the panel is actually built into a component of the building, where it takes the place of the roof rather than being on top of the roof, or it takes the place of a window rather than being mounted over a window. A shingle or a roof tile or an awning or a deck roof can become the solar panel, and that's called a building integrated system. And the third technology that local government people really need to be thinking about is how the system is or is not hooked up to the larger energy system in our community. Grid intertie systems are where the solar system is connected through the house to a larger energy system, in this case the electric grid. In this case, no energy storage is needed. You don't need a battery because you basically use the grid itself as the battery. When you overproduce compared to the needs in the building, you just put it out onto the grid, and then later when you need that energy you pull it back in and you're credited at an equal rate to what you pay the utility for electricity. Then there are systems that do require storage, and these are primarily water heating systems, although there are some battery electric systems as well. This is important because when you are using a storage system, the system has to be designed in order to match the load in the building, and that means that it's much more sensitive to things like the pitch of the system at certain times of the year. And these things come into play depending on if you're installing a solar thermal or a PV system on your roof, and the way the technology fits into the building and the consequences of that as it relates to the solar resource on the law. So anyway, that's our technology primer, and now I want to start talking about how the planning element, kind of best practices for local governments in terms of how local governments do local planning and how the solar resource plays into that. And the kind of critical issues to remember about this whole discussion are, one, that renewable energy is an important local resource. It's very substantial in your community. It is something that has economic value, and thus it is an important local resource to consider during planning processes. Second, people in your community will want to take advantage of their renewable energy resources. This is something that's distributed across property lines. Every lot, or almost every lot, has some solar resource, and because it's an important economic value, people will want to take advantage of it. Consequently, communities will need to make decisions about how and where solar installations are to be done. And this is where local governments are a critical partner in this market transformation effort. So when we talk specifically about planning, and the comprehensive plan in particular, solar energy has some very interesting places that it should fit in, but it rarely is fit in to comprehensive planning. Part of this is that solar energy is perceived by many people as a property right, that they have, it has economic value, the sunlight falls on their property and they should have an economic right to capturing it, but in fact there is no federal constitutional protection to access for sunlight. So when people talk about solar access as it relates to either things on their own lot or in adjacent lots, there is no constitutional protection for it at the federal level. However, the bundle of rights that comes with owning property, while it does not include a right to direct sunlight, it can be created by either state action or local law. So in Minnesota, we do not have any state action that's been taken to create this solar right, or there have been other states that have done that. But local governments can actually decide to kind of protect this perceived right through local action. And so this is where, when we talk about local planning, we need to think about the solar resource as our local resource. In the metropolitan area, in the 7-county metropolitan area, communities are actually required by state statute to address direct sunlight for solar energy systems as part of their comprehensive plans. It's in state laws, it's stated here. However, this provision, protecting and developing access to direct sunlight for solar energy systems, has been really given perfunctory attention in the planning processes that we've seen in the past. But since this provision was originally put in place in the 70s, there's been an evolution of local government best practices for protecting and developing the resource, and there are now some new opportunities for metro area communities to meet this statutory standard, and of course greater Minnesota communities to look to those best practices to address the solar resource in their community as well. So when we think about your community's solar resource, what does this really mean in a planning context? Well, we have to understand that there are geographic elements to the solar resource, that it's not everywhere. There are some places that's better than others. There are technology characteristics. How do you harvest this resource, and what kind of implications does that have for planning? And then third, markets. What is the use of the resource? What gives it value? How is the value affected by local regulation? So kind of the understanding solar energy, the geographic characteristics, is something that you can actually map out. And here what we're seeing is a map of the light rail corridor between downtown Minneapolis and St. Paul, downtown St. Paul, that has been mapped for its solar potential. And you can see the two downtown areas in blue where there's lots of tall buildings, and consequently a lot of the solar resource there is very, very spotty. The blue means that it's a poor solar resource. On the other hand, you see red areas or bright orange areas where either the topography or some geographic feature shows that there is a good solar resource there on a year-round basis. You can see Interstate 94 cutting between the two communities, where the north side of the interstate is an excellent solar resource because there's no buildings or trees on the interstate, and so it's an unimpeded, has unimpeded access to direct sunlight. The blue line that kind of runs down, you can see the south bank of the Mississippi River, where it is in shade most of the time. Therefore, it is a poor solar resource. So there are these geographic characteristics, and you can see the grid pattern of the local streets kind of playing out the same way, are important to understanding how your community can and cannot take advantage of this local resource. This has actually been incorporated into planning efforts, and here is in Olmsted County as an example. This is actually for wind energy, but it gives it a good example of how geographic elements of energy can be thought about. They specifically developed a resource protection area, recognizing that there are site-specific meteorological characteristics, sites with high potential for wind energy production based on land cover, land uses, elevation, topography, etc. The same kind of thing can be done for solar energy. You can recognize where you have good resource and where you don't, and accommodate that in the planning process so that you don't end up impacting the resource by doing development that doesn't accommodate it. Similarly, the City of Minneapolis has a provision in their policy on expanding the use of renewable energy to take measures specifically for the protection and development of access to solar energy and wind power. And this is a very basic kind of comprehensive plan standard, but one that does provides the foundation for local action to take place. Second, we have this technological characteristic. When we talk about sand and gravel mines on the left, you can see we understand how that particular resource is harvested. It has economic value, but there are certain nuisance impacts associated with it, and we also we understand that we don't want to be developing on top of, we don't want to be putting housing or buildings on top of these resources because they ultimately have to be removed when you want to get to the resource. Agriculture in the center picture, we understand how those resources are harvested. They have important economic value. We need to take these kind of harvest resources into consideration when we do our planning in rural areas where there is agriculture. And on the right, we see an oil refinery, again recognizing that that particular energy source has certain technological harvesting characteristics that have impacts on surrounding land uses. So what does that mean for solar energy? We have different kinds of ways to harvest energy for our solar resource as well that have different kinds of land use impacts and different kinds of aesthetic impacts, from non-flush mount systems on rooftops to building integrated systems on the right to pole-mounted systems out in an area that has no building on it but has a good solar resource. These different things have different impacts on the community and on surrounding properties. City of Shakopee is an example in their comprehensive plan recognized this, where they identified that there were different types of protections for different types of technologies, and this is right in their comprehensive plan. Rooftop protection, south lot protection, detached collector protection. This is elements that recognize the different technologies needed to harvest the solar resource on the lot depending on the characteristics of that resource. And then the third element in a comprehensive plan, we talk about economic characteristics. How does the resource have or give value to the local community? And here showing the creation of jobs, particularly the installation jobs there in the second bar. That is a local job that will always be a local job. You can't export that to China like you can, in theory, manufacturing jobs. And so this is something that will always have local economic benefit. Here's another example using wind energy in Stearns County, where they actually wrote this into the economic development policies of their comprehensive plan, both in terms of encouraging economic development on agricultural producers' land to buttress the economic viability of agriculture as a economic asset to the community, and also recognizing the sustainable development benefits, the kind of substitution economic development benefits of using a local resource versus a non-local resource. The Minnesota Solar Challenge is working with the Metropolitan Council on some of these things to help metropolitan areas, local governments introduce solar into their comprehensive plans. We've already modified the local planning handbook to address some of these issues in a more clear way, and identified sources of information such as the information packet at the National American Planning Association. This is a huge compilation of examples of different kinds of things in plans and zoning ordinances that is free of charge from the national APA. But as we talk about kind of zoning, now we'll move into those best practices. So once you have solar energy in your plan, you need to start talking about how do you actually address it in your regulation. And development regulation and zoning can have a pretty big impact on the ability of people to take advantage of their own solar resources on their lot. When we start getting into solar zoning, however, we need to think about conceptually what is it you're trying to do, the kind of questions you need to ask yourself before writing your solar ordinance. How does your comprehensive plan address your community's solar resource? You need to think about those things that we just addressed in a way to make sure that there's a foundation for taking action in your community. How does your existing ordinance affect solar energy installations in terms of potential barriers? There may be unintended barriers to solar development in your community. What are the potentially competing property interests around developing your solar resource? There are some people who think that a solar panel going up on the roof is a great thing for their home, and their neighbor may think it's a terrible thing that's affecting the property value of his home because there's this hideously ugly solar panel in his or her humble opinion that's driving down their property value. This is something we see fairly frequently in terms of kind of potentially competing property interests. What are the potentially competing community resources? The one we see most frequently are solar energy is a great thing. It's a local resource. Urban forests are great things. They're a real resource. They add value. Both of those things add value to property, but they are competing with each other. Most comprehensive plans address both. Well, when they address solar, they also probably address urban forest. How are those things overlapping, and how does the community figure out what is a priority and when is a priority? And then finally, you need to ask when you want to encourage action or just settle conflict. Are you just, in your zoning ordinance, are you just going to try and take care of the nuisances and kind of settle the conflicts, or do you actually want to set some standards and take advantage of certain tools that are available to local governments in terms of setting incentives within your development regulation so that the solar development can occur in your community on a more expedited basis? We're going to be using some examples out of the model ordinance for sustainable development here that we developed originally for the Environmental Quality Board and then updated it for the Minnesota Pollution Control Agency. However, we've been continuously updating this model ordinance for solar energy standards as we've been running through this Solar Challenge project as well. I'm going to be using examples out of this. This is available to anybody who wants to see this particular model ordinance so that you can see how there is at least one example of how solar can be incorporated into a community. And the ordinance is written as a pretty standard standalone ordinance, including a scope and purpose, definitions, as well as basic zoning issues, advanced zoning issues, and incentive issues. So the primary standard that we want to talk about here is that in zoning we want to minimize conflicts and create transparency and predictability in the regulatory process. We're not trying to to give an exception for solar energy except to the extent that the local government wants to do that. And to minimizing conflicts and creating that transparency and predictability, we need to look at basic zoning and advanced zoning. And then if you want to talk about proactively encouraging solar development, you can talk about things like incentive zoning and solar regulatory requirements. But the first thing that everybody needs to think about is the basic zoning issues, using basic zoning tools to address solar installations, particularly uses, setbacks, heights, and actually coverage ratios are things that are typically almost every zoning ordinance has, and they have an impact on how solar resources are developed in your communities. Are solar land uses allowed in your zoning ordinance? Most zoning ordinances don't even mention solar energy. Well, are they allowed or are they not allowed? It's a pretty easy step to just say that we should allow them, make sure that they're allowed in order to allow a property owner to develop their solar resources. Do the existing standards, such as setbacks or height standards, create barriers to capturing solar resources on a particular piece of property? And do the existing standards that you have allow for flexibility when solar resources may be not quite as accessible as we would like them to be, but unless we allow some flexibility, for instance, if the only solar resource on a lot is in the setback area. So an example of that in the model ordinance is just some simple language that says solar systems shall be allowed as an accessory use in all zoning classifications where structures of any sort are allowed. This is a pretty easy thing to put into an ordinance, but it's something that actually can have a big difference in terms of making the process predictable and transparent to someone who actually wants to take advantage of their solar energy resource on their property. Similarly, height requirements. Well, how does a height requirement affect solar energy? Sometimes the solar resource, where there's optimal solar resources, requires you to get up pretty high above things that may be shading the rest of the lot. Do you want to allow solar resources or solar installations to exceed your height limit or not? There are some things that are allowed to exceed height limits in most jurisdictions, such as antennas or chimneys, things like that, because they need to get above the building in order to function properly. Sometimes a solar system needs to get above the building in order to function properly. But this is a question that you as a community need to decide. Are you going to allow it to go over the height standard or not? Are you going to allow people to capture the solar resource if the only place they can get to it is over their roof, above their roof, or not? Similarly with the setback requirement, and this is one that actually talks about a roof setback, but similarly you have setback issues, side setbacks, for instance, if you have an awning that is a solar system or a ground mount system that is the only place that it will function properly given the solar resources, it has to extend into a side yard or even into a front yard sometimes. The setbacks affect where the resource can be captured on a given lot. And here's an example in the city of Woodbury where they adopted some solar energy standards. You can see in the subsection A there, they said that it is an allowed or permitted accessory use in all zoning districts. They specifically said that building integrated systems are exempt from the requirements, so therefore they kind of made sure that that was a safe area for people to develop their resource. They had a height requirement there where they said you must comply with the maximum height requirement. So they made a decision in this case not to allow people to exceed the height requirement for a solar energy system, even if that precluded them from developing. And that's a decision that every community needs to make. City of St. Paul, on the other hand, allowed people to go above the peak of the roof explicitly. They created what they called a solar envelope, where you have an as-of-right development standard for solar energy systems, up to 3 feet above the ridge of a roof for residential development. That's an example of basic zoning. Here's some examples of advanced zoning, where we talk about things like design standards. How do you address community aesthetics or character standards as part of your local regulation? Some communities do this, some don't. So this is why we call this advanced. It gets to a different kind of set of tools. Another couple of examples of that are homeowners associations frequently have some kind of a design review. Does the community have an interest in ensuring that in those areas solar development rights are maintained? Because the local government can say that homeowner associations, on a forward-going basis at the very least, need to not preclude solar systems. And then there's a question of cross-property protection. Do you want to enact solar easements or some other kinds of protection on somebody's long-term investment that they're making in solar energy on their property? And here's an example of a design standard that a community might put into place, where you say if the solar system faces the public right-of-way, then we want to make sure that it's a flush mount system, that it is not a system that is non-flush mount, such as you see on the left there. The system on the left is on the back side of the house, and this particular ordinance specifically says that if it can't be seen from the public right-of-way, this particular aesthetic issue does not restrict the way that solar can be developed. So it carves out, and again, an as-of-right development under zoning, flush-mounted on facing the public right-of-way, non-flush-mounted is fine when you're in the backyard. And similarly, here's an example of how, under this particular model, no homeowners association or common interest community can be more restrictive than the city's design standards. Or you could simplify this and just say that no homeowners association can preclude solar development as part of a design review, putting only reasonable restrictions on it. It just makes sense. You can develop, you can mix these two goals, aesthetic goals, and solar development goals in a way that makes some sense and that allows both to proceed in a reasonable manner. Here, the City of Roseville addressed this by adopting the concept that roof or ground mount solar systems shall not be restricted if the system is not visible from the closest edge of the public right-of-way. On the other hand, they said that the visibility is a concern to the city, and that they want the systems to be designed to blend into the architecture of the building as much as possible, particularly when the building is seen, or when the system is seen from the public right-of-way. City of St. Paul also had a visual impact characteristic of their zoning ordinance for rooftop equipment, but they specifically wrote a set of guidelines that defined how that visual impact is modified or is interpreted in regard to solar energy systems, such as permitting solar energy access while minimizing visual impacts, that any mitigation that's required on visual impact must consider the function of the solar installation and not detract from it. That visual impact is assessed primarily from public streets, as we just noted in the Woodbury example, that it can be reduced by integrating into the roof design, such as making sure that the panel, what you see from the roof, from the public right-of-way, is the panel surface rather than the racking system, and then a specific allowance for solar energy systems to be above the peak of the roof when needed. As I noted earlier, that kind of solar window that they have defined that is as of right. Solar access is something that communities can look into. The state law does actually specifically allow communities to put in place something called a solar easement. Here is the actual statute, and you can look this up to get the full set of standards for how a community might enable such a thing to go forward, so that a property owner could actually buy an easement across his neighbor's property to make sure that his long-term investment in solar was not going to be impacted by tree growth or buildings that would be going up over that. Similarly, there is a written into state statute the concept that inadequate access to direct sunlight for solar energy is explicitly a hardship under the state statute for variances. You cannot grant a variance just for economic hardship, but you can grant a variance because someone can't get to their solar energy resource. So even in the case where your zoning ordinance may preclude development of solar resources, someone says the only place I can get to my resources in the front yard, they can actually come in and ask for a variance, and if the city chooses, could actually grant the variance and allow it to go into the front yard even though their zoning ordinance says otherwise, if they determine that that makes sense within the context of their community. And then we have zoning barriers, going beyond barriers and talking about regulatory incentives, and there's a variety of things that are in the model ordinance that talk about this, and I'm not going to go into them in detail here, but this is where you really want to actually start putting things in place that encourage or incentivize solar development in your community. Because I do want to save some time here to talk about permit fees and permit processes. When we talk about here we're talking about building code and how someone actually obtains a building permit, which is not going to be applicable to every community in the state, but to most developed places they do issue building permits. And the permit process is really a critical part of making sure that the solar energy system and solar energy development is going to occur in the most cost-effective way and is self-sustaining over time. We want to reduce time spent on acquiring permits and conducting inspections without impacting the important function that that permits and inspections play in ensuring that there's good and quality development occurring in your community. You just want to make sure the permit process is transparent and predictable to people on both sides of the counter. So when someone goes up to the building permit, you have staff knows what the standards are, the contractor knows what the standards are, so that everybody's on the same page and there's not conflict or misunderstanding. You want to make sure that the permit process reflects industry best practices, and this means that as much as possible we want every community to be adopting the same conceptual process for pulling solar energy permits, so that it's the same when people go across jurisdictions, or similar when people go across jurisdictions. And finally, we want to establish a permit fee that appropriately covers both local government review and local government inspection costs. That's the state standard. The permit fee is only supposed to cover these costs. It's not supposed to be used as a revenue, as most people in local government know, but there are some particular nuances about solar development that make this particularly problematic in the way we typically do charge our permit fees. So let's talk a little bit first about the permit process itself. And I just want to note that all of the stuff we're talking about here is based upon a national document called the Expedited Permit for Small-Scale PV Systems. And it's difficult to read. This is a one-page permit process that many communities out in California and West Coast and even some East Coast, New Jersey and New York, use this kind of a permit process to recognize that residential small-scale PV systems are actually relatively simple in terms of the building permit process. They're more complex in regard to electric permits, but for building permit, it's a fairly straightforward installation. So the permit process identifies when a permit is required, it collects basic information, identifies minimum submittal requirements and criteria, and submittals with electric systems as well, and that's what this particular process does. You can get the full expedited permit process from the Solar America Board of Codes and Standards at this website. It's a fairly lengthy document, but it is the national best practice that we've used here in Minnesota to develop some models for local governments. And in particular, we did this for the cities of Minneapolis and St. Paul. They have a solar permit checklist that they developed that actually takes the place of their building permit, or I guess it defines the building permit process explicitly and tells you several things. One, of course, the checklist identifies when it's applicable. It collects the basic information similar to the expedited permit, identifies drawings and technical information that is needed in order to acquire a permit in the cities of Minneapolis and St. Paul, identifies when structural engineering review is necessary when you're doing a retrofit to a residential roof, and also identifies criteria or other permit processes that are required so that the contractor understands that they, in some cases, are going to need, for instance, historic preservation review in addition to just a building permit. I'm going to run over some of the specifics of how that works in the city of St. Paul, and I do just want to emphasize that every local jurisdiction needs to adapt this in a way that makes sense to their community, and Minneapolis and St. Paul have some of the more complex and thorough permitting processes in the state, but they managed to do this, and if they can, then anybody else in the state can do it as well. So here we have an example of how in the checklist it says the permit checklist applies in certain circumstances and not in others. For instance, it does not apply to building integrated solar systems. In that case, the solar system is considered to be part of the building. It is not a separate solar system, and we're not going to regulate it as a solar system. If it's a roof, it's a roof. It's not a solar system. If it's an awning, it's an awning. It's not a solar system. Second, the St. Paul permit and the Minneapolis permit identifies the required drawings that are needed and the technical information that has to be submitted in order to pull a permit. And it's all laid out right in the checklist, including an example of the kind of a cross-section that the permit officials in Minneapolis and St. Paul decided that they wanted to make sure that the contractor had demonstrated that they had looked into these things by having them diagram it out in a fairly simple and straightforward manner. The permit checklist also identifies when structural review is necessary for residential installations on modifications of existing roofs. And this is something that had to be tailored very carefully to Minneapolis and St. Paul. They have a particular age of building stock, a particular kind of structure that was typically seen, and they spent a good amount of time assessing where they could draw a bright line about when a structural study was needed and when it was not needed. And this is particularly important to the contractor in terms of kind of market transformation, in terms of developing a self-sustaining market in solar energy, because a structural study will cost about $700, and that's, you know, in the same realm as the contractor's profit margin on a solar system. And so if they don't think they need a structural assessment and they go into the permit counter and suddenly they get told, no, you have to go out and do a structural assessment, they've already made the bid, they've already been awarded the contract, they now either have to go back and they have a very unhappy homeowner, or they have to give up most of their profit margin. And that's kind of what we want to avoid. We want this to be transparent and predictable when that kind of structural assessment is going to be needed. The other elements that go into the permit checklist are standards for ground mount submittals, so that when, again, contractors know exactly what they need to bring to the permit office in order to get a permit. The electrical information, and this is something that happens in the city of St. Paul. Minneapolis has the state look at their electrical, do their electrical inspection, and so there is no part in their checklist for electrical information. So this again is something that varies community by community. And then of course the heritage preservation standard, where both cities determined that they wanted, as part of the building permit process, for the contractor to look up on the city's website to determine whether or not heritage preservation review was going to be needed for the particular installation, so that there weren't any surprises, because there's no way around doing heritage preservation review. It's going to take more time, and it's good that everybody would know that ahead of time. Now I'm going to talk just briefly about permit fees. Most local governments in Minnesota, when they issue a building permit, they base the permit fee upon the value of the work to be done, which makes some sense, because the more expensive project is going to be a more complex project. The more expensive project is going to require more review on behalf of the local government. It's going to require more inspections, or a greater sequence of inspections, and so that makes some sense. Except it really doesn't make a lot of sense necessarily for solar energy systems. What we typically see for a solar installation, when you're talking $15,000 to $25,000 of an installation, resulting in a permit fee of $400 to $800. In fact, we've seen a few that have gotten up as high as $1,000. But this is for an installation that basically can take place in most circumstances, in 2 days. So what other $25,000 project is going to be done in 2 days? You don't find that. The cost of the system does not reflect the complexity of the system as it's going up, nor the need of the city or county to spend time on plan review and multiple inspections. It's usually a fairly simple inspection process. So the best practices that we talk about with permit fees are, one, to continue to use your valuation-based system, but exclude the cost of the solar panels or the power electronics or both. That dramatically reduces the cost of the system on the permit fee basis, recognizing that really what the local government and the building permit is inspecting is the racking system and how it's attached to the roof. That's the main thing, and then any structural changes that are made to the roof in order to support that are the things that drive the cost. And so those costs all make sense, and they do in fact reflect the amount of effort that the local government needs to go through in terms of plan review and inspection. A second option is to actually set a fixed fee, and this only works really for residential installations, not for commercial. But to set a fixed fee based upon what your internal costs of review and inspection are, which can be anywhere from $100 to $250. Usually there's only a single inspection that's needed. It's a fairly quick review on the documentation that has to be submitted. Minneapolis and St. Paul, with their permit checklist, they've actually gotten the permit application process down to as short as 45 minutes, where they can just look at the information. It's check, check, check. They can see it's all there, and it's done. The inspection, again, is usually for the building permit is usually just a single inspection to make sure that the system is going up in a manner that is reflective of what the permit application drawings showed. So it's a fairly simple process. Communities already do this kind of thing for certain other kinds of residential installations, such as roofing. A single flat fee for a roofing permit, regardless of whether or not it's a small roof or a big roof. It's basically the same amount of effort by the community to review and inspect that system, and so in recognition of that, they have a flat fee rather than a valuation-based fee. So this is not something that's new or unusual in communities in Minnesota. The third kind of best practice is where you actually want to use an incentive, such as waiving the fee because maybe for a couple of years because you want to encourage solar development in your community. This is something that's not, to my knowledge, been done in Minnesota. It has been done in other states, but I do put the caveat on here that, of course, building departments are expected to raise revenues, their own revenues, to support their building departments. So if you're going to pass an incentive fee, do recognize that. And in your general revenue allocation, and allow your building department to do their inspection without having to find it, take it out of some other pot of money. So here's an example of, and this is from the City of Austin, of one of those residential fees that is a flat fee for a roofing application. It doesn't matter what the size of the roof is, it has a flat fee based upon just a couple of characteristics. I didn't talk a lot about other code issues. I talked mainly just about the permit process and how cities manage that. Of course, there is a whole other set of issues around the code itself and how solar fits into that. Building inspectors and code officials may have some real questions about how, for instance, particularly on the electric side, the National Electric Code and the Minnesota State Electric Code deal with solar energy and what are the best practices associated with that. There's actually a training that code officials can go to. This was developed by the National Renewable Energy Labs in conjunction with code officials. It's online. You can go to the website here. It is free. You can, your code officials, I believe, can actually get continuing education credits if they apply for that with their certifying entity. So it's a good thing to do, and it is something that's also accessible to people who are not code officials but want to learn the technical elements of how photovoltaic systems fit into the building code. This is the structural engineering study for Minnesota residential rooftop solar installations. We did it specifically for thermal installations. We did this a couple years ago, had an engineering study done. You can access that if your code officials want to talk about where to draw that bright line for their community about when a structural assessment is going to be needed and when it is not. This does address only rafter-based systems because we were doing this for Minneapolis-St. Paul, but it does shed some interesting light and helps people get a sense of where some of those bright lines might be. Now, the Minnesota Solar Challenge is offering technical assistance to local government. I just wanted to briefly run down what that means. If you are a local government and you want to adapt these best practices to your community, we have this technical assistance available. It's only available up to February 15th, so we have a very short window now, only 2 months left in this process. But basically we're doing workshops even at the local government level for specific audiences, helping people understand how they can adapt the best practices to their community. We're providing assessment of existing plans, ordinances, and permitting processes to tell you what the barriers in your ordinance or your permit process might be to local solar energy investment. We're making recommendations on the basis of those assessments to how to adapt best practices, and in some cases we're even writing draft language for guidance documents specifically for local government that they can then take for adoption with their planning commission or their city council to be reflective of the conditions in their cities. So we're going to be helping at least 20 communities here. We currently have 15 signed up, so we have slots for at least 5 more. You can go to the CERTS website, Clean Energy Resource Team website, and access the intake form and get on the list. We encourage you to do so, and we want to help as many cities as we can in the remaining 2 months of this program. So thank you for your time. Here is some contact information. The Minnesota Solar Energy Hotline, Stacy Miller, who's the project manager for this overall project. You can reach her and get help for all of your solar energy questions at the number at the top there. My contact information, and then Laura Sina, who's the Minnesota Renewable Energy Society team leader for the solar coordinator, her contact information also. So I guess that concludes the webinar, and we're going to take some questions now.
Hey Brian, I've got a question here about incentives. Are there tax incentives or rebates available for individuals to install solar?
There are incentives available for individuals. It does vary across the state. There's a federal tax credit that's going to be available through 2016. It's 30%, and it's a tax credit rather than a deduction, so it's quite a nice little incentive for people to install solar. There are also some incentives by local utilities, depending on which utility you're served by. Xcel Energy has a $1.50 a watt incentive. Several municipal utilities in southern Minnesota have a solar rebate as well. I believe the city of Brainerd, the municipal, has a solar rebate, and then Minnesota Power has a rebate. So check with your local utility on whether or not they have a rebate program and whether or not it has money in it for the year, because sometimes they do get oversubscribed for a year. They usually budget for it on an annual basis.
We have kind of a related question here. Someone's wondering if anyone has approached local credit unions or banks to get private financing options?
We do have a financing element to this the Solar Challenge work. We're not doing it directly as part of the Solar Coordinator team, the part that I'm involved with. However, if you contact Stacy Miller, she can kind of tell you what's happening around financing issues. There are actually some state policy initiatives that may be introduced this year that will make financing easier and allow local banks to be engaged. There are also some installers who have approached local banks or credit unions in order to kind of develop a package, a financing package that can be done as part of a solar installation bid that they put together, so that you can get a bid for not only installation but also how you might finance it. And Stacy can give you a little bit more information on that at the number listed on the screen.
So here's a good one. This person's asking if there's any local research or documentation regarding solar and property values.
There has been some. This kind of goes to that sense of when you put a solar panel on your roof or in your lot, excuse me, what happens to the property value of the structure, home or business? The research that's been done on this has been pretty conclusive, where in places that have a robust solar market, which is mainly out in California and in New Jersey on the coast, that solar systems have a distinctive improvement to property values that needs to be taken into consideration kind of economically. This is not a matter of just a simple payback, how much energy savings you can get, but also how much property value is going to be increased by the installation of the system. Unfortunately, we don't have any information in Minnesota specifically about this because we just don't have a robust market yet, and not enough statistical data. We don't have enough cases to demonstrate that the difference in property values across two similar properties can be attributed to solar energy.
So here's one more, and I think you probably have a good answer for this. Has there been any talk of using local energy cooperatives to encourage solar energy installations?
Well, local energy cooperatives, that's kind of an interesting idea. I mean, we can look at co-ops, and there are electric co-ops, of course, that provide electricity, and some of those are participating in solar rebates or other kinds of initiative, and one in particular has actually done what's called a community solar project, where people who may not have a solar resource on their rooftop or on their property but still want to buy solar energy can do so along with a group of other people at an off-site location, what we call community solar. And one actual co-op has done this in Minnesota, and there are some other pilot projects planned for this. This is being done on a large scale in the state of Colorado, called the Solar Gardens that they're doing out there, where they're getting thousands of people actually getting together and buying a share of a solar system, which is then, the production of the solar is then taken directly off their electric bill, so that they don't have a solar system on their property, but they do have one. They do get the benefit of that. And so we will have some pilot projects happening in Minnesota probably soon. So keep an eye out for that as kind of a local co-op kind of concept, community solar.
And then here's maybe a good one to wrap it up. Is there info available on the other two goals of the Minnesota Solar Challenge, improving net metering and financing options for solar?
Yes, there is information on that. There's several processes going on right now at a policy level. The state has been undertaking what they call their distributed generation kind of dialogue that they've been engaging over the last about year and a half with advocates and property owners and industry and utilities about how to encourage distributed generation in the state. The Solar Challenge has been participating in that, as well as a few other initiatives. And again, this is, and then on the financing question similarly, the best way to get your questions answered about specific elements of that is to call up the Minnesota Solar Health Hotline, talk to Stacy, and she'll be able to give you a rundown of the things that are happening there related to the Solar Challenge and things outside the Solar Challenge in terms of policy.
All right, it looks like I'm not seeing any other questions coming in here. So,
okay, well thank everyone for their time, and please go to the Clean Energy Resource Team website and sign up for technical assistance so that we can make sure to get you in the queue. And I look forward to helping your community address the barriers of solar energy and create a local self-sustaining solar energy market.
Great, and you can all just go to cleanenergyresourceteams.org and then look for the link for the Minnesota Solar Challenge. Thanks.